Hi guys, right, today we're going to look at differentiating some other trig functions. So I'll start off nice and easy. Let's have a look at sec. Well, sec x is 1 over cos x, which is cos x to the minus 1. So if I wanted to differentiate sec x, I could think about using this and then perhaps use the chain rule. So the differential of sec x with respect to x, you need to get used to writing that sort of terminology down, would be, so differentiate the outer function, so minus 1 times cos x to the minus 2, and then we're times by the differential at the inside times minus sine x. So what we get is these negatives cancel out sine x. Because we've got a negative power here, that would be the cos squared x. And I'm going to separate that to be the same as being sine x over cos x times 1 over cos x. So that is tan x sec x. So there's the first one. So let's have a look at cosec x. And that is sine x to the minus 1. So the differential of cosec x is going to be the differential of sine x to the minus 1, so that's minus sine x to the minus 2 times by cos x. So that would be cos x minus cos x over sine squared x, which is minus cos x over sine x times 1 over sine x. So overall we get minus cot x sec x. So it shouldn't be a surprise to see the link between the two. You flip that upside down, so that's what gives you the, sorry, that should say cosec x. You flip that one upside down, so that's what gives you the cot instead of the tan, and the differential of sine and cos, that's what gives you that negative there. And you can see the two are very much closely related. Now if I was to look at tan x, this is a little bit trickier. So tan x equals sine x over cos x. So I'm going to use the quotient rule. I'm going to say that u is sine x, u by dx equals cos x, v equals cos x, and dv by dx equal to minus sine x. So when I write down my quotient rule formula, dy by dx is equal to v du by dx minus u dv by dx over v squared, I get overall v times du by dx, that's cos squared x, minus, and then u times dv by dx is minus sine squared x all over cos squared x. Now you can see here cos squared plus sine squared, that would be 1, equals 1 over cos squared x. So actually that comes to sec squared x, and that's one that you definitely need to remember. The differential of tan x gives you sec squared x. Must remember that. Now let's look at cot x. That equals cos x over sine x. This 1 over tan. So u is equal to cos x. Du by dx is equal to minus sine x. V is equal to sine x. dv by dx is equal to cos x. So, writing out my formula, dy by dx is equal to v du by dx minus u dv by dx over v squared, and that would come to v times du by dx is minus sine squared x, and take away u times dv by dx, and that's cos squared x, and that's over v squared, which is sine squared x. And what you should see, that is minus 1 times sine squared x plus cos squared x over sine squared x. And you know that that equals 1, so it's minus 1 over sine squared x, which equals minus cosec squared x. And there's a relationship there between, here we've got tan and sec squared, and cot and negative cosec squared. You often find that relationship going on. So here we've got cot and cosec squared related, where tan and sec are related. They are similar functions or similar relationships. There's often just a negative that makes the difference. Again, I would say that's the one to remember. The rest of these you can think about. I think some of them may be in the formula book. I saw that come up in an integration question the other day. Integrate cosec squared x, and that was an expected knowledge one. So if you can't remember it, know how to quickly run through this quotient rule and you should get to it. Other than that, that's it. Thank you.